Today we will be talking about radicals. And let's first say what this is. So we're first going to define what these are. Definition. For any integer n that is either greater than or equal to 2, so that could be 2, 3, 4, 5, 6, all that kind of stuff. The principal nth root of a number a is defined as the nth root of a is equal to b if b to the n is equal to a. The principal nth root of a number a is defined as the nth root of a is equal to b if b to the power of n is equal to a. So what I mean by that is that if I have the cube root of, let's just say 8, the cube root of 8, what I want to know is what to the power of 3 gets me 8. I want to know what number to the power of 3 is equal to 8. If you think about it, you can see that we should get 2, because 2 to the power of 3, which is like saying 2 times 2 times 2, is equal to 8. So the cube root of 8 is equal to 2. Again, the reason behind that is because 2 to the power of 3 is equal to 8. Now, let's try to do the cube root of 64. The cube root of 64. Now again, what that means is I want to know what number raised to the power of 3, because we're taking the cube root, what number to the power of 3 is equal to 64. So to know that, I just try things. So let's try 1 first. Let's see if I can do 1. 1 to the third, it's like saying 1 times 1 times 1, which is 1, which is way off. So we don't want 1. Let's try 2. 2 to the power of 3 is 2 times 2 times 2, which we already said was 8. So it's not 2. Let's try 3. 3 to the power of 3, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Also wrong. Let's try 4. 4 to the power of 3, that's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Since 4 to the power of 3 is equal to 64, then we know the cube root of 64 is equal to 4. Now, let's try this one. Let's try the example. The fourth root of 81. The fourth root of 81. So for this one, what I want to know is what number to the power of 4 is equal to 81. Again, let's just try stuff. Let's try 1 first. 1 to the fourth, 1 times 1 times 1 times 1. 1 times 1 is 1. Times 1 again is still 1. Times 1 again, still 1. 1 to the fourth is 1, so clearly we don't want 1. Let's try 2. 2 to the power of 4. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So we don't want to use 2. Let's try 3. 3 to the power of 4. 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 9 is 81. Since 3 to the power of 4 is equal to what we want inside of here, then we know the fourth root is equal to 3. And now let's try this one. example, the square root of 25. Now notice here I said square root, but I did not write down a 2. If you have a square root sign with nothing written up here like a 3 or a 4, we assume we are talking about the square root. Again, if I don't have something here, like I don't have a 3 or a 4 there, I assume we are talking about the square root. So what I want to know is I want to know what squared is equal to 25. If I did 1 squared, 1 times 1 is 1, no good. Try 2 squared, 2 times 2 is 4, no good. Try 3 squared, which is 9, 3 times 3 is 9. 4 squared, 4 times 4 is 16. Try 5 squared. 5 times 5 is indeed 25. So since 5 squared is equal to 25, the square root is 5. One more time. If there's not a number outside of the square root, we assume it's the square root. So what happens if what I have inside of my square root sign is not a perfect square? So what if there isn't a number I can square and get that thing? In this case, we use the product rule for radicals. And what this says is that if inside of my square root I have something like the square root of a times b. So if I had like the square root of 2 times 4 or the square root of like 3 times 8, if I had the square root of stuff times stuff, what I can actually do is I can split that into 2. So I could write that as the square root of a times the square root of b. We are going to use this for if what I have inside of my square root is not a perfect square. Okay? So this is how to simplify some radicals. Again, I do this if what I have inside of my square root is not a perfect square. Okay? The first step, write the inside as a product. Where one of the factors is a square. We're going to rewrite the inside as a product so that one of the factors is a square. Once I do that, I split it up using this rule we just had right here. After that, use the product rule. Now let's see exactly what I mean by this. Let's do the example. Square root of 48. We're working with the square root of 48. 48 is not a square. There's not something I can square to get that. So therefore, I can't get just a plain thing like I did with the last ones. Okay? So I want to try to split this up by taking out any perfect square that is there. If we have a square root, we do not want what's inside of it to have a factor that is a perfect square. Okay? We do not want the inside of it to have a factor that's a perfect square. So what I want to do is I want to look at 48 and see if there's a perfect square inside of it. Remember, our squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, on and on and on. Okay? I want to make sure that 48 does not have a factor that's one of these things. And if I look at my list right here, I can see 16 is a factor. I can do 16 times 3 and get this. Since 16 is a square, I do not want 16 inside of my square root. So what I do is I rewrite this as the square root of My perfect square is 16, so we're going to do 16 times 3. Again, the reason I chose 16 is because it's a perfect square. Okay? So now, using my product rule, I can rewrite this as the square root of 16 times the square root of 3. And this is great because the square root of 16 is 4. So I can write this as 4 times the square root of 3. I know to stop when what's inside of my square root no longer has a factor that's a perfect square. 3 is not a square, and it does not have a factor that's a square. So we're good right here. Now let's say we did not pick 16. Notice I could also do 4 right here. I could have done 4. 4 is a square, so I could have picked 4 to put right here. Let's try that and see what happens here. So we can rewrite this to be the square root of 4 times 12. Split it up into two things. Square root of 4 times the square root of 12. Square root of 4 we know is 2. So I can write this as 2 square roots of 12. That's right. However, the problem here is that 12 has a factor that is a perfect square. 4 is a factor of 12. So we can't stop yet. So if we did this, that's fine, but we cannot stop until what's inside of my square root no longer has a square. So I'd have to keep on with 12 now. I can rewrite 12 as 4 times 3. Split that into two things. Square root of 4 we know is 2. So from the square root of 4 we get 2. 2 times the 2 we already have is 4. So if we multiply this 2 times 2 from the square root, that's 4. So we still end up with 4 square roots of 3. Either way, we're still right. 1. Now let's try this one, this example. Let's do the cube root of 250. Now I'm working with a cube root, which means I want to take out all of my cubes. Whereas on the last one, I had a square root, so I took out all of my squares. Now, since I have a cube root, I want to take out all of the cubes. 1 cube is 1, 2 cubed is 8, 3 cubed, 27, 4 cubed, 64, 5 cubed, 125, on and on and on. I want to see if any of those are a factor of what I have inside of here. 250 can be rewritten as the cube root. This I can rewrite as 125 times 2. Since 125 is a factor and it's a cube, I have to take it out. I can split this up into 2. Cube root of 125 times the cube root of 2. Cube root 125 is 5. So this is 5 cube roots of 2. The last thing we want to do is learn how to rationalize denominators. What I mean by that is there's a math rule, a math law, that says radicals, which is the square root sign, radicals cannot appear in any denominators. A radical cannot appear in the denominator. But let's think about what I would do if I have that. What can I do to make it to where that's not true? Okay? How I do this, step 1, actually the step, multiply the numerator and the denominator by a radical that makes the denominator a perfect power. Multiply the numerator and the denominator so that the bottom is now a perfect power. So if on the bottom I have a square root, what I want to do is times the top and the bottom by a square root so that the bottom is a perfect square. The reason why is because if I take a square root of a square, that's just gone, right? If I can take the square root for a square, that's just gone. And so I want to make the bottom a perfect square if I have a square root. So let's say we had this example. 3 over the square root of 2. Like we said, we do not like it when we have a square root down here. So we want to get rid of it. So what I'm going to do, since I have a square root, I know I'm going to multiply the bottom and the top by a square root. Again, that's because I'm wanting to get rid of the square root. Okay? Now I want to know what I can times 2 by so that I have a square. And I can see that if I do 2 times 2, I get 4, and that's a square. So I want to multiply it by 2. If I do it down here, I must do the same thing to the top. Again, the reason I picked 2 is because 2 times 2 is a square. So we're wanting to do that so that inside of my square root, I have a square. So now on top, I have 3 times the square root of 2. Down here, square root of 2 times the square root of 2. 2 times 2, I get 4. So this is the square root for 4. And we all know that the square root of 4 is 2. So now I can rewrite this as 3 square roots of 2 over 2. So what I did was I wanted to make what's inside of the square root down here a square. So I can do 2 times 2 to make it a square. Take the square root of it, and we get 2. So what if I had one that was like this? Square root of 3 over the square root of 50. Again, the only square root I don't like is my square root that's down here. So I want to get rid of that. Since we have a square root, we know that we're going to multiply by square roots. So now I want to know 50 times what is a perfect square. Well, I think about it and I realize I can do 50 times 2 and get a square. 50 times 2, 50 times 2. Because on top I would now have, since they are both inside of the square root, I would do the square root of 3 times 2, that's 6. And then if I do 50 times 2, square root of 100. If I work this out down here, we realize we get 6 over 10. What I meant was that we get the square root of 6 divided by 10.